Theoretical recap. Before diving into the simulator, let's consolidate what you've covered so far. A network is a set of interconnected devices, hosts, that exchange data through links in the form of packets. Each packet carries a source and destination IP address, allowing routers to make forwarding decisions. Switches operate at a lower level, forwarding frames based on MAC addresses within the same local network, while routers connect different networks by reading IP headers. A network flow is simply a sequence of packets traveling between two endpoints, for example, your browser and a web server. Each flow has observable properties: protocol, TCP, UDP, ICMP, source/destination IP, port numbers, and direction. In cybersecurity, understanding flows is critical. You cannot detect anomalies or attacks if you cannot first read normal traffic. A common beginner mistake is confusing the path a packet takes, routing, with the content of the packet, payload. Another is assuming all communication is point-to-point. In reality, a single web page load generates dozens of distinct flows. Keep in mind, topology matters. The same packet behaves differently depending on whether it crosses a switch or a router. Use Cisco Packet Tracer or a browser-based simulator like Cisco Packet Tracer Web, GNS3, or NetworkMap.net to make these flows visible and tangible. This workshop puts all of that into practice. Workshop brief. In this workshop, you will use an online network simulator to build a small network topology, generate traffic between hosts, and observe the resulting network flows step by step. The goal is not simply to make things work, but to understand what you are seeing, which device handles which packet, at which layer, and why. This is a foundational skill in both network administration and cybersecurity. You cannot analyze, pen test, or secure what you cannot first visualize. You are recommended to use Cisco Packet Tracer, free to download with a Cisco Net ACAT account, or if you prefer a fully browser-based option, Packet Tracer Online via Cisco Skills for All. Both are acceptable. If you are already comfortable with GNS3, you may use it, but be aware it has a steeper setup curve and is not required at this stage. Step 1. Build your topology. Create a small but realistic network in the simulator. Your topology must include at minimum 2 end hosts, PCs or laptops, 1 switch, 1 router, and a second network segment with at least 1 additional host. Assign coherent IP addresses to each interface and host. Use private address ranges, for example, 192.168.1.0 out of 24 and 192.168.2.0 out of 24, and make sure your subnet masks are consistent. Configure the router with 2 interfaces, 1 per segment. Do not use automatic configuration tools blindly. Type addresses manually so you understand what you are setting. Step 2. Generate and observe ICMP flows. Once your topology is configured and all links are active, check for green indicators in the simulator. Use the simulation mode, not real-time mode, to send a ping from a host on the first segment to a host on the second segment. Step through the simulation packet by packet. For each step, observe which device is currently processing the packet, what the source and destination IP addresses are, whether the packet is being forwarded or dropped, and which interface it exits from. Pay close attention to what happens at the router. This is where inter-network routing occurs. Capture or note down your observations. You should be able to answer: how many hops does the ICMP request take? What does the reply path look like? Does the IP address change at any hop? Why or why not? Step 3. Add a TCP flow and compare. Now simulate a TCP-based flow. In Packet Tracer, you can use the built-in HTTP server and browser simulation, or simply use a generic TCP connection between 2 hosts if HTTP is not available in your setup. Step through this flow the same way. Note the differences. TCP requires a 3-way handshake before data is exchanged. Identify the SYN ACK, and ACK packets in the flow. Observe how many packets are involved compared to a simple ICMP ping. This contrast is important in real traffic analysis and pen testing. TCP flows are far more common and carry application layer data. Step 4. Introduce a misconfiguration and diagnose it. Deliberately introduce an error into your topology. Change the default gateway on one host to an incorrect IP, or assign a wrong subnet mask. Then attempt to ping across the network. Observe what happens in simulation mode. Where does the flow break? Which device drops the packet? What error is returned, if any? This exercise mirrors real-world troubleshooting and is directly relevant to understanding how misconfigurations create attack surfaces or blind spots in network monitoring. Fix the misconfiguration and verify that the flow works again before moving on. Step 5. Document your observations and reflect. Prepare a written summary of your workshop. This document should include a screenshot or diagram of your final topology with IP addresses labeled, a description of the ICMP flow path, step by step, a description of the TCP handshake flow you observed, a brief explanation of what broke during the misconfiguration step and how you diagnosed it, and a short reflection, 5 to 10 sentences, on what this exercise reveals about network flows from a cybersecurity perspective. Think about questions like, what would an attacker see if they were positioned between two segments? Which device would be the most valuable to compromise to intercept traffic? How does understanding flows help you prioritize where to look during a pen test? You are allowed and encouraged to consult your previous course materials, Cisco documentation, and any relevant internet resources. You may work with a peer or ask for help, but the written reflection must be your own. The recommended time to complete this workshop is 2 hours. Submit your documentation, screenshots plus written summary, as a PDF or zip file, before the deadline. Late submissions will not be accepted.